At the recent Open and Innovative Education Week, hosted by the Open University of Hong Kong, Dr. Anatoly Gruzd from Ryerson University in Canada made the following workshop presentation. Dr. Gruzd explores and assesses methods of analyzing and making more sense of patterns of communication and relationship in social media settings, and he looks at ways in which such knowledge can be applied in educational settings.
So, today there are a couple of things we're going to try to cover. First, we'll look at how you can collect data from social media. Then we're going to discuss the methods, a particular method that can be used to analyze social media data, which is social network analysis. After explaining basics of social network analysis, we'll look into how can we use social network analysis to analyze online discussions. We will look at the visualization techniques as well as more analytical approaches, how to measure the impact of discussions on online classes. First, let's just think about it, social media data more broadly. We know that social media platforms are becoming increasingly important in our daily lives, and more people join them every day. So in addition to more people joining these platforms, they also contribute more data. Because every time they leave a comment or post or like something, those interactions are being recorded. And so follow this trend, we also see social media platforms offering more ways to collect and analyze this type of data. Here are just three basic examples of how we can capture social media data. Starting with the most popular one, so something we call public APIs. API stands for Application Programmable Interface. It's on the left side of the slide. And they are offered by social media platforms themselves, like Facebook. The other way, a bit easier but more expensive way, is to go with data resellers. So there's also a huge new industry emerged around big data and social media data that essentially partnering with social media platforms such as Facebook, Twitter, and they then offering to resell bulks, so full access to this type of data sets to researchers like yourselves or industry and businesses. Finally, many researchers would also develop their own tools and techniques to collect data from participants. So it could be as simple as survey, it could be more advanced online application or mobile application where students or other participants will contribute some kind of data that you can analyze. Now, so we know that, as I said, more people joining social media websites, more data available. There are different ways to access the data. Now, well, once we access it, what kind of things, what kind of tools do we need to keep in mind to make sure that it's useful for us to have access to such data? So there are four different categories that I identified here that we want to discuss a bit. Let's start with the cloud and distributed computing technology. Because of the big size, large scale, and dynamic nature of data sets that are coming from social media platforms, you really need to think about distributed and cloud solutions to store this type of data sets. So there's certainly need for such platforms because maintaining your own servers sometimes, again, can be very cost prohibitive. And sometimes you don't need to have access 24/7 to a very large server. So cloud computing allows you to create a virtual machine, virtual server, for a period of time that you just need it. And you pay essentially for that particular period of time. So the other class of technology that we want to touch on and discuss today related to data and information organization. So essentially, once you decided what cloud computing and distributing service you want to use for storage and analysis of your data, next step would be to decide how do you organize your data. Is it going to be stored as a file, one file, single file, as a database? What kind of database? And we know that traditional databases are not well equipped to work with large dynamic data sets, such as those that come from social media data. So as a result, a new generation of databases emerged. Of course, the answer and the type of technology you're going to use in your case will depend on the type of data you have and the type of access you need, how often you're going to read and write to that particular database. But once you decide on how to organize your data, the next step would be to decide how do you analyze it. What are analytical tools and techniques you're going to use? And there are plenty to choose from. maybe sometimes too many. But here's some examples. So Python and language R emerged as one of the leading languages in data analytics. So not just in educational field, but many other fields prefer to use these tools to run different experiments, to analyze data. In part because there are many developers contribute different libraries. So if you want to do text analysis, there is a package in R, and there's a package in Python language that will help you to do text analysis. If you want to do network analysis, there are packages for that as well. As part of the analytics, and here I listed as a separate component, is visualization. And sometimes it's a next step, sometimes it's the step just before you do the analysis. Why? Because visualizations are effective in trying to see what's in your data set before you can actually test things statistically. But visualizations are also great at the end of your research projects to demonstrate some of the results that you found using more formal statistical tools. The challenge, of course, how do you have time to learn all these tools, right? Or do you have resources to hire experts to work with all these tools? And these tools change all the time as well. Luckily, there are a number of web-based applications out there that simplify our life as researchers. They allow us to collect data easily from social media. They allow us to analyze data and visualize it. In the social media lab, we maintain a toolkit, what we call a kind of directory of those popular social media analytics tools that you can also use for your works. Here, we included some most popular tools and indicated whether they support text analysis, network analysis, what kind of visualizations they support, what kind of files you can export it out. Because as researchers, we often don't stay with one particular tool, right? So we can start a data exploration in one tool, then we move it to another tool, then we use third tool to visualize it or publish results and so on. So for us, it's important whether a tool can support the expert features. And as well, we include some links to published articles that use the tools, which is a great way to see, well, how other researchers use these technologies. All right, so let's step back and say, okay, there are many different ways to analyze data. But today we have limited time. And so if we want to learn something, what that little something we can do today? And I decided that it's useful to talk about social network analysis as a method to analyze structured as well as unstructured data, but more importantly, analyze conversational data. As you know, a lot of online education rely on discussion forum or some kind of platforms that allow students and instructors to interact with each other. And it's really critical to have tools and techniques to understand and analyze this type of data. So when we're talking about analyzing data using social network analysis, essentially we're saying we want to take data we got and represent it as a graph. So on the right side is a graph representation of whatever data we got. And the graph can represent a lot of different things. But first you have to start to say what each dot in that graph means in that network. The dots usually refer to people, and if we study in online classes, these would be your students and instructors, maybe guest speakers, and so each dot is a person. Connections can represent a different type of things. So if you study in online discussion forums, then the connection often indicate who replies to whom, so who talks to whom in the forum. But sometimes you might be studying relationships, social relationship, collaborative relationships. And so then the connection can indicate, let's say, who works on the same project with whom. The advantage of once you have this network representation of a class or communal discussion or collaborative work, then you can answer very interesting set of questions. You will see how people interact with each other, who are the most or least active member of a community or class, who influential member of the group, and who is susceptible to be influenced. And so depending on where the dot or person located in the network, whether the person in the center, on the periphery of the network, whether there are clusters formed. So here's the picture example of one of paper with my colleague Jeffrey Roy that we did based on Canadian federal election. And in that particular case, we look at how Canadian citizens were engaged in political discussions during the election cycle. And we saw a lot of polarized discussions. Different people leaning to different political parties, so Liberal, NDP, Conservative, they would be mostly talking to each other. but we also saw opportunity for cross-party discussions there. So that's why you see a lot of lines. So even though there are groups of nodes of the same color representing same political interests, there are also connections in between them. So there are opportunities for discussions. So this is advantage of having the network data, because you can have a better understanding of what's happening in a particular group, online or offline. But there's, of course, challenge of how do you collect this type of data. Traditionally, you would have to conduct surveys or interviews and ask everybody in a group to contribute the data. For example, if we have about 30, 40 people here, I would have to print out a list of all of you on one page, and each will get that page as a copy. And then there will be questions such as, can you indicate people who you know? Can you indicate people you're working with? Can you indicate people you collaborated within the last months? And so on. So it's a very time-consuming process, and it will make you also uncomfortable, so because questions tend to be sensitive. As a result, we don't know how objective answers would be, or complete or incomplete answers. And people also forget interactions, or whether they had interactions with other people. Furthermore, imagine doing something like that in the context of online learning, especially if you're teaching massive open online course, such as MOOCs, that can include hundreds and sometimes thousands of participants. So clearly, it's really hard to scale up methodology. So we need to think about other approaches to collect network data. And luckily, there are a lot of different network type of data sets available in social media. So we can think of forum networks when somebody is replying to somebody else in online discussions. We can think of blogs networks. So if you have a blog and somebody linking from their blog to your blog, you of course have friends networks when people self-declare their friendship relationship on websites such as Facebook. You can also have networks of like-minded individuals who may or may not know each other, but they indicated interest in the same area. For example, you watched YouTube video that you like and you hit like button, and somebody in this room also liked that video. Maybe you don't know each other yet, but you clearly share interests. So networks of like-minded individuals also quite useful, and often being used by recommender system to recommend people you might want to get to know in the future, so recommend friends. So now that we know there are quite a few different ways to collect different network data from social media, let's dive into a more specific area, so online discussions. A lot of classes will be based on text-based conversations. And so the challenge is, how do you go from threaded discussions like this one to a network representation? Because that's our goal today, to represent discussion data as a network, and then see what kind of answers and questions we can ask this data set in the network format. Let's start with a basic type of data, emails. How do you convert emails into network data? So emails are great examples because every time you send a message, you also indicate who should receive this message. So who are the addressees of the messages? So you can use that information to indicate who sent message to whom, who replied to whom. And of course, the tie strength, what we call the strength of the connections of these lines, can represent how strong the connection is. You can quantify it by saying, okay, we're going to say the more messages you exchange with each other, the stronger your connection is, the better you know that person. Of course, as a researcher, you have to be careful with defining the strength of a tie. Why? Because sometimes strong connections will use multiple channels of communication. So I'm thinking about my colleagues back in Canada, and quite often I send them messages. But because they're in the same building, quite often I just stop by and have a face-to-face interaction. And so always keep in mind that there are interactions that you may not capture through a particular data set. Now, going from email types of data, where you clearly know who's supposed to receive your message, to online discussions data, a bit more challenging. Why? Because by definition, social media data or forum discussions are many-to-many type of conversations. Why is it many-to-many? So I'm sending a message, posting a message on a forum, and anybody can read it. So that's why it's too many. But also many can reply to my message. So that's why it's called many-to-many. So as a result of this, we don't really know who's supposed to receive this message and who's replying to whom. Sometimes one person can hit the reply button on my message, but they might be talking to somebody else in the class. And so it gets very confusing at the end. So how do you derive who actually paying attention to whom in this class? Who replying to whose messages? And there are different approaches, of course, to derive network data from this type of forums. So if you look at the literature, most common approaches would rely on just if you click reply to somebody's message, then you must be replying to that person. This is more straightforward approach, and most of the time it does show interactions, but in my own work, what I found that even better approach is to look whether people mention somebody by name, especially in online contexts where you're studying collaborative learning. You want to know that whether people replying to someone because of a particular idea they like, or they disagree with this person, or whether they're replying because they know that person by name. And so when they're using personal names quite often, that type of interactions would indicate stronger social ties. So you can find collaborative connections through that. But when somebody replying to someone without naming them by name or usernames, it's quite often because of the topic they like. So that's why we have to think about carefully, how do we represent this type of data as a network data? And because today we're talking about social media data, and specifically I'm going to be using Twitter as a platform, instead of calling someone by name in the message, you use their username. So you start the message with @, and then the username will be @John or @Peter, @Paul. So here's an example, a very simple network of 3 users of this platform, John, Paul, and Peter. And you can see John and Peter essentially talking to each other. Peter sent 2 messages to John, and John replied to Peter once. Then you have Paul and Peter. So Paul mentioned Peter, but Peter never got back to that person. So we're not sure how strong that relationship is. It's kind of one way at this point. And so what's also important, what's not here. So we don't see interactions between John and Paul. And as educator, imagine you see this network, and these 3 people may be working on a group project together. So the problem here right away that, how come they're supposed to be working together, but John and Paul, they just don't talk to each other? That's something strange. So here's maybe opportunity for you as instructor to have some intervention, maybe to meet or send a message to this group to say, how are you doing? Do you need any help? Now, just some specific examples of Twitter messages. Let's say this is my message, so from Anatoly Gruzd, and I'm starting this message on Twitter, starting with the username of my colleague at a different university. And her username is Sydney Eve. So I start the message @Sydney Eve. So it's a reply to her message. And I'm thanking her for helping me to share some information online. So it's a direct reply. So as a result, if we try to derive a network, to build a network based on this interaction, there will be a connection from me, from my user account. In this case, it's just my last name, Gruzd. So @Gruzd, connecting to my colleague @Sydney Eve. So that's how you convert text data to network data. And you repeat it based on all of the messages you have in your data set until you get the whole network. But there are other forms of interactions in social media, when people just mention someone. And these are just as important as direct replies. Because when we mention someone, we're trying to get their attention. So we're saying, hey, we know you exist. We were paying attention what you're doing. And those mentions can also lead to more engaged conversations between individuals later on as well. So when we mention someone in social media, on Twitter, we can mention their username inside the message. So here's a user, Florence. She posted a message saying, report by @JoeProf. So that's another user who published some report on how consumers dislike #DataMoney. This message also mentioned another user @VMoscow, and then URL to New York Times article to this report. So what happened is the report by one user, this is the person who actually wrote that article in New York Times, and our Florence user mentioned both of them. So as a result, we can now derive a network data using the mentions information, so connecting her user account to 2 users mentioned in the context. So one connection will go from her account, GFlow, to JoeProf, and another to VMoscow. What is also important, we can say, hey, because 2 users mentioned together in the same message or same sentence, or within a short proximity from each other, we can connect them as well. Because, well, clearly there is some context that exists that make them be mentioned together. So they maybe know each other, or maybe they share same interests. Remember that network of like-minded individuals, just as important. So we can connect Joe Prof to Vimoskov. So again, and you repeat this process for all of the messages in your data set, and then you get a network. And so before we jump into the learning analytics context, I thought it's easier to show you the contrast. We're going to look at two different topics before jumping into the learning context again. And then you're going to see a clear difference between one type of topics and the other type of topics and what kind of networks they generate. So we're going to use two popular examples. One is hashtag election 2016. So I'm going to use a sample data set that I've collected back in November to demonstrate what kind of networks we can build from that data set. And the other example is a very open-ended search that I've conducted. I said, can I find all the messages that mention Hong Kong? You know, it can be anything, but as long as people say, hey, this message is about Hong Kong. So I've collected two data sets, and then I visualized them. I applied the technique that I just described, and I received these two network pictures. So they're quite different visually. Let's just look at them and try to figure out what's happening and why they're different. But first, I want to remind you that each dot here will represent a user of this platform, in this case, Twitter user. And connections will represent interactions. So it's either somebody replying to someone or mentioning someone. So these are the conventions that Twitter platform allows us to use to build, to know who is paying attention to whom. The colors here is assigned automatically. So the colors help us to identify groups of users, so clusters of people who tend to talk to each other, but don't talk to everybody else in the group. On the right side, you have more distinct groups of different colors. So there are lots of what we call isolated clusters. And we'll talk a bit about that, implications of that later. Now, so let's go and see why they are different. And what can we learn from these visualizations? To answer this question, we need to know some specific measures, social network analysis measures that we can apply, we can calculate using some software. There are many social network packages that can do that. But we need to know what do we want to calculate to tell us more about these networks. We can see visually they are different, but we need to have measures to describe this difference. And there are two types of measures that exist. So one that describe individual nodes. So what I refer to as micro-level measures. And these are different centrality measures. So you have individual dots in the network, and you want to know how influential they are. But there are different ways to define influence. Somebody is influential because they share a lot of resources with other students. Somebody influential because they reply to many other students, and so on. So there are different mathematical formulas essentially defining this influence. The other side, macro level, will describe the network overall. So the whole class, let's say. You want to have one measure, multiple measures that will say how this class is different from that class. And again, there are more than 5 measures, of course, but these are my favorite ones. So density, diameter, reciprocity, centralization, and modularity. And we're going to go through each of these micro level and through each of the macro level measures. And we will use them to say, hey, why this network is different from that network. All right, so let's start with micro level measures, centrality measures. So in-degree centrality usually suggests prestige of a person. So people who have been mentioned or replied to people will have high values of this measure. So to demonstrate that, I will use Hong Kong example. So this is data set that anybody who posted a message on Twitter, public messages, and mentioned Hong Kong as a topic. And so we want to know who are the influential people based on in-degree centrality. So this is when connections goes in that person, so other people mention that person. And this sample data set I've collected last December, and this was time when here in Hong Kong they hosted the Asian Music Festival award ceremony. And so a lot of messages actually related to that festival. And so when we look at some of the most influential accounts that have been mentioned, so that have high in-degree centrality, like this one, Pleiades_17, these often relate to music groups, to different bands that participated in the festival. And so they have a lot of fans, and this is happened to be account for a South Korean group called 17. So they have a lot of fans, and the fans mention them a lot. So that explains the high in-degree centrality. Now, if we switch back, so instead of counting in-degree centrality, how often people reply to you or mention you, let's count out-degree centrality, how often you or other people mention others or reply to others. So often people with high out-degree centrality will have a good awareness of other people in the network. So they are very useful individuals, especially if you want to, let's say, go into in-depth and interview some of your class participants to know how well the class was happening. But you don't have resources or time to interview everyone in the class, especially if it's an online environment. So you might want to interview people with high out-degree centrality because they clearly refer and reference many other people in the group. So let's use again an example of Hong Kong Twitter network and see who are the people with high out-degree centrality. So here's an account, Dragonfluer 1989. So the person has high out-degree centrality, and so the person is located in this cluster, but I just zoom in kind of to show you the actual network picture. And again, what happened is a music fan of a particular group, and the person replied and mention many other people. So that's why the person influential, so they are trying to engage everybody else in the group. That explains why that person has high out-degree centrality. The third most popular measure, so there are three most popular, and there are a lot of other centrality measures that you can explore later on. So today we're only going to focus on the first three. So as this third measure suggests, or its name suggests, it's called betweenness centrality. It's about a person being between different groups. So you're influential because you connect in different clusters. Because without you, there would not be information flowing between one cluster to another. So that's why you're influential. You're a gatekeeper between those two or more communities. And so again, going back to our examples of Hong Kong Twitter network. And so if you zoom in here, you have a user account here connecting two clusters. And so that person is influential according to betweenness centrality because of that connection. If you remove this dot, the two clusters will not be connected, and they might not be able to share information. So that's the influence coming from. But by itself, the person is not influential according to in degree or out degree because he or she has only few connections. I think there are only 3 connections. So when we look at some of the messages, so this is public Twitter messages, it's another fan, and again, a lot of messages about that festival and groups. And the fan essentially mentioning and retweeting messages from 2 different fan communities. So there are different websites that exist to support different groups, or the same group but different communities, and that person is aware of different groups. If we're thinking about educational context, these are also useful individuals in the network because they might be aware of diverse resources that may be useful for a particular assignment. So they can draw from this resource and from that resource. And so the end product may be more useful from those individuals because they can bring diverse reference or resources. The second step, of course, to describe the network overall using macro level measures. All right, so macro level describe the network overall. And again, there are more than 5 measures. These are most popular ones. Density is the simplest one. It defines as overall connectivity in the network. It's calculated based on the total number of connections in the network divided by the total number of possible connections. So essentially, if everybody is talking to everyone in the class, density will be equal to 1, right? So sometimes, as an instructor, you want to design a class so that everybody can have a chance to discuss with each other, and everybody is inclusively participate in the conversation. So you want to have density as high as possible. The range is from 0 to 1, so 1 is maximum. And this is a sample network of 3 users. When they all connected to each other, density will be equal to 1 because there are 3 possible connections, and there are 3 connections exist. So 3 divided by 3 is 1. for these two networks, again, we're comparing two examples, just to contrast. So the density for the election topic, 0.005. If you multiply this measure by 100, you can use it as a percentage. Sometimes it's much easier to understand what's happening with the percentage. So in the election topic data set, only 0.5, so less than 1% of connections exist. But you think it's small. But if we look at the Hong Kong example, and so multiply that the density value by 100, only 0.04% of connections exist. So in Hong Kong network, there are much fewer connections than there is a potential. There's a potential to have more. But because of this clustering effect, so you have lots of different pockets, and essentially it's because there are different groups of people talking about Hong Kong in different contexts. Somebody can be talking about finance. Somebody can be talking about hiking and nature and trails. Somebody can be talking about entertainment. And so as a result, these are different clusters, different groups of people. They don't talk to each other. And as a result, the density will be much lower. When on the election topic, you would expect, even though people might not know each other, they're all using the same topic, same hashtag, election 2016. So they will be able to see each other's messages. And so there's a chance that more of them will be engaged in the conversation. So diameter is an interesting measure. It gives a general idea how wide the network is. And it's important because it shows how long it would take for information to go from one side of this network. So let's say this is network. So somebody started a message here, and message goes, and we count how long it takes, how many connections it takes to get it to the end of this network. So in this simple example of 4 users, you have the diameter equal to 3. Why? Because you're looking for the longest, shortest path. The longest path is to share information between user 1 to user 4. So if you go from user 1, 2, 3, you need to have 3 connections until you reach to user 4. That's why the diameter is 3. So you're looking for the longest path. If user 1 talks to user 4, so if we have this connection here, then what would be the diameter of this network? Any guesses? It is 2. Because the longest path will be, let's say, you need to share information between user 1 and 3. It requires 2 connections, 1 and 2, because they're not connected. Or if you want to share information between user 2 and 4, it also requires 2 connections. So it doesn't matter if we have this connection. We still have at least 2 connections to go through. So the diameter will be 2. All right, so for our 2 sample networks, numbers quite different. And we like seeing differences because it highlights also different nature of conversations. For Hong Kong example, the diameter actually is smaller. And this is, indicates limitation of this measure, because this measure doesn't account for disconnected clusters. What it does is looking for the largest cluster in the network, and it measures this longest path in that cluster. So if you don't see that picture, and don't have any other information, and looking at diameter, you may perceive that the discussion about Hong Kong is very connected. The paths much smaller, half of that for election. But it's only because this measure, diameter, doesn't account for disconnected clusters. So because information doesn't really flow between them. On the other hand, the election 2016 topic, more people connected, so it's a larger cluster, and density represents that. And diameter 28, so it does take quite a while for the longest path, so 28 connection, I mentioned that. But it also represents that this discussion, it spans across many communities. And sometimes you won't have that value higher, especially if you're designing a viral campaign. So some kind of marketing campaign about Open University, and you want to have more people talking about Open University. So you actually would want to see a larger diameter because it will say that, hey, it's actually worked. Our viral campaign spread across many communities. If the diameter is small, it may indicate that, oh, it stayed within a smaller cluster. Reciprocity is one of my favorite measures, and it's very easy to understand. It calculates interactivity. Most of the time when we design online discussions, we want to have interactions. We don't want just our students post messages. We want them to reply to each other. Sometimes we have to require X number of replies, but sometimes it happens organically. So you can have two different discussion forums, and one will have very high interactivity and one will low. And so you want to figure out what makes that forum more interactive. But how do you even know how to measure interactivity? So reciprocity is one way, most common way to measure that interactivity, because it counts the percentage of messages that would go both ways, two-way conversations. So in this example, we have, again, 4 users, and in reciprocity will be equal to 1. This measure ranges from 0 to 1. If you multiply it by 100, it will be percentages, right? So 1 is 100% of connections that are both ways, two-way conversations, which is great, right? So if I reply to someone, that person will reply to me back. Not like in the case of celebrities, when people try to get their attention, they never get back to you. So, but this scenario is not very common, especially when we analyze in social media data. And you will see, based on our 2 networks, the reciprocities tend to be smaller. But that's why it's so important to compare that measure against other data sets. So you can see whether your value is lower than expected than everything else or higher than expected. So jump into these 2 examples that we got, election 2016 and Hong Kong example. You can clearly see that the election example twice as interactive. Both measures are small, right? So one is 0.006, the other is 0.003. But relatively, we can see that the topic of election 2016 triggers more interactions. And again, that makes sense because they're all talking about the same topic. And sometimes somebody says something you don't like or you like and you want to reply, you jump on it. With the Hong Kong example, because of this clustering effect, different topics, you might be using the same hashtag. I might actually see that message. But I'm not interested in this, videos or music or travel, depending on whatever you're talking about. So I won't reply. So as a result, reciprocity is a bit lower. So if you have 2 classes and one class has reciprocity this, the other class that, and you have same number of participants, same assignment, clearly something about the first class that created more interactions. Sometimes it's just personalities, right? Sometimes it's just a set of students in your class that tend to be more open. But sometimes it could be an instructor. Maybe instructor a bit more effective facilitator of discussions. Let's finish up. Let's talk about centralization and modularity next. So centralization indicates whether a network is dominated by one individual or by many. So if you see centralization value is close to 1, it's bad. Usually it's bad because it means that one individual dominates the whole conversation. And so sometimes you get students who really overly, overposting. And then that sometimes discourages other students in online discussions to post as well. So if you see pictures like this in your network visualizations, then maybe you need to interview. You need to say to that individual, hey, maybe you want to allow other students to participate. So somehow to involve more people in the discussion. So essentially, user 1 is that person who controls the information in that network. And why? Because user 2 and 3 are not connected. User 3 and 4 are not connected. So there are no connections in between these users. So the only way for user 2 to share information with user 3 is to go through user 1. And same for other ones. So that's why we would say that the power, information power, whatever you study, is concentrated in hands of one person. This is very rare in reality that you get centralization equal to 1. But there may be fewer individuals, very popular individuals in your class, or more active students in your class that will dominate the discussion. Of course, it depends on the assignment, right? If you're designing that, you're grading a person for their moderation and facilitation of discussions, maybe you want to have that person centralization to go higher. But if it's a general discussion, perhaps you want to look for lower values. These are centralization values for our 2 networks. Quite low, relatively low. But again, we're comparing not the absolute values, but relative to each other. So for Hong Kong example, that network is more centralized. And you see why. There are clusters there. And within those clusters, there are popular individuals. The only reason this centralization value is not any higher, not closer to 1, because we have multiple clusters. Because this person and central person in that cluster doesn't really control this cluster. But within the cluster, there are stars, what we call them. Here, more people are connected to each other. There's no set of users that dominate discussions, so the result centralization is very low. So that's we would perceive as a open, democratic kind of conversation. A lot of people engaged and feel comfortable contributing to the discussion. Finally, so we're almost there. Last measure. So modularity. And modularity is the most complicated measure in terms of calculating it. But again, software does it for you. We just need to understand what does it mean, whether its values are closer to 0 or closer to 1. Again, range from 0 to 1. So the measure provides estimate whether a network consists of one coherent group of participants who are engaged on the same conversation and paying attention to each other, so then the values will be closer to 0, or whether a network consists of different conversations and communities with a weak overlap or no overlap, then the values will be closer to 1. So if we're thinking about two examples, election and general topic on Hong Kong, we can expect to have modularity higher for Hong Kong for sure, because we already saw there are different clusters, disconnected clusters. For election, we expect to have values lower because we saw there's a denser group in the middle. Not everybody were connected to everyone, but it should be less than 1 for sure. So let's see what we get. So indeed, so there's a big contrast between the two networks. In Hong Kong example, you can see the modularity almost maximum, so close to 1, 0.92. And that kind of reflective of this network visualization where you have multiple different clusters, disconnected clusters. On the other case, you have more moderate values, so 0.446 for election, indicating that there is a shared conversation happening on the same topic. And so it's kind of I purposely picked these two data sets because one is more focused discussion, right? The other is more generic one. But this is also demonstrate how do you interpret the values if you see the values studying online, learning discussions, right? Studying online class. Because if you see values like for Hong Kong, then maybe it's a bad sign. You wanted everybody in the class to be part of the discussion, but what you see is people are staying in their little pockets, right? So not engaged across the class. So that is a very useful measure to understand the whole network, instead of looking at individual dots, individual points. All right, so we covered 3 objectives of the workshop already. Thank you for attending the workshop. I look forward to learning about your work. So thank you.